Om Swastyastu, Assalamualaikum Warahmatullahi Wabarakatuh, Syallom, Namo Budaya, and good to see you all guys. Now back to my video and my presentation, Metallurgy in the chapter of the cast iron. And my name is Yudis Chrisantya. I have name is 23055311063, and our lecturer is Professor Dr. Tjokorda Gde Tirta Nindhia MT M Eng. And in this material, we got Metallurgy with the code TM2301. I'm from Mechanical Engineering Technical Faculty, Udayana University. And this is my presentation. I take my reference from a book Metallurgy for the Non-Metallurgy Second Edition. It's edited by Arthur C. Reardon. In the chapter Cast of Iron, we have 7 sub-chapters. The first is Basic Metallurgy of Cast Iron, Classification of Cast Iron, Gray Cast Iron, Ductile Iron, Malleable Iron, Compacted Graphite Iron, and Special Cast Iron. In the cast iron like steel are iron-carbon alloys. The difference is that the cast irons typically possess higher carbon level than steel, so that cast iron can take advantage of eutectic solidification in a binary iron-carbon system. Now we go to the first is the basic metallurgy of cast iron. Cast iron are the heterogeneous, multi-component ferrous alloys that solidify with eutectic. For example, when an iron with a 2.5% Celsius C is as cooled below the liquid line. White and gray cast iron, the iron solidifying with an austenite graphite eutectic has a gray fracture surface appearance, while the one solidifying with austenite Fa3C eutectic exhibit a wild fracture surface. Sometimes a mixed structure of gray plus white tone model may occur. In controlling the eutectic reaction, to control the properties of cast iron, it is necessary to control the formation of the carbon-rich phase, the eutectic reaction, and the formation of the steel matrix, the eutectoid reaction. In a typical cast iron composition, a cast iron can have a composition that makes it hypereutectic, eutectic, or hypereutectic with regard to carbon. Its position in this respect is important because it determines not only the initial solidification points in the liquidus, but is also a factor in whether an iron solidifies with a gray, white, or mottled eutectic. In a matrix microstructure, in addition to the carbon-rich phase, cast iron gray, nodular, compacted, and malleable have a matrix, the steel structure that may consist of ferrite, perlite, bainite, and martensite, and austenite. In a gray iron, the S-cast matrix is predominantly perlite. So it's like we can see in here that consists of alternate layers of ferrite and iron carbide, Fa3C, or cementite. And in the heat treatment, iron casting affords the designer a desirable selection of mechanical and physical properties at low cost. This decline has been due in a part to the ever-tightening control of chemical composition and processing. And heat treating is used to relieve internal stress, improve machinability, increase toughness and ductility, increase strength and wear resistance, reach a necessary step in the production process, that is, austempering gray or ductile irons, producing malleable iron casting, or annealing iron cast in the permanent molds. Next, we go to the classification of cast iron. The historical classification of gray and white cast iron based on fracture appearance still applies today. Cast irons are also classified as either common or special cast iron. Common cast iron are for general purpose application and are unalloyed or low alloyed composition. A general classification of cast iron by name and metallurgical structure is provided in here. For common cast iron, the range of alloy with carbon and silicon varies by the type of iron. And in the gray cast iron is the most common form of cast iron and is characterized by a microstructure with flakes like lamellar graphite embedded in a steel matrix. Graphite shape in a gray flake graphite irons. Standard have been used for many years in the evaluation of graphite size and shape in a gray irons. In ASTM A247, for example, the flake graphite in a gray cast iron is described by the following types. The A type, uniform distribution, random orientation. In the B type, reset grouping, random orientation. C type or type C is superimposed flake size, random orientation. Type D is interdendritic segregation, random orientation. Type E, interdendritic segregation, preferred orientation, and the type F, Wittmann-Stedin graphite. On the other hand, the following properties decrease with the increasing tensile strength. So the low strength irons often perform better than higher strength irons when these properties are important. Machinability, resistance to thermal shock, damping capacity, ability to be cast in this indent section. In the ductile iron, also known as nodular iron or spheroidal graphite irons, is a very similar to gray iron composition, but during solidification, the graphite nucleus has spherical particles in a ductile iron rather than as flakes. In the casting of ductile irons second only to gray iron in the amount of casting produced, account for over a third of all casting, ferrous and non-ferrous. In the heat treatment and mechanical properties of ductile irons, many ductile iron products are used in the as-cast condition, but in some foundries, approximately 50% of the products are heat treated before being shipped. And in the malleable iron, the historical of malleable iron goes back to Europe. The French scientist and metallurgist R.I.F. de Reaumur published at the first technical discussion of malleable iron casting in 1720 to 1722. In the compact graphite iron are the newest member of the cast iron family to be developed as a distinct category. The application of compact graphite iron stems from their intermediate position between gray and ductile irons. Compared to flake graphite iron, compact graphite iron have certain advantages. First, higher tensile strength at the same carbon equivalent. which reduce the need for expensive alloy elements such as nickel, chromium, copper, and molybdenum. Much higher ductility and toughness, which result in a higher safety margins against fracture, lower oxidation and growth at high temperature, less section sensitivity for heavy section compared to ductile iron. The advantages of compact graphite iron are lower coefficient of thermal expansion, higher thermal conductivity, better resistance to thermal shock, higher damping capacity, better cast stability leading to higher casting yield, and the capability for puring more intricate casting, improve machinability. And last we go to the special cast iron. In the special cast iron are typically high alloy irons, which can be classified as either white or graphite irons. And here we have graphite free and graphite buried. In the graphite free, we have a paralytic white iron, martensitic white iron with an Ni hard, when high chromium iron, and 11 until 28% Cr. In gray and ductile iron, small amounts of alloying elements such as chromium, molybdenum, or nickel are used primarily to achieve high strength or to ensure the attainment of a specified minimum strength in heavy section. Okay guys, that's all my presentation about chapter 10 is cast iron. I'm very apologize when there is some problem about my presentation. And the last, I will say in a permanent Santi, Om Santi 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 Om. Assalamualaikum warahmatullahi wabarakatuh. Syallom, Namo Budaya, and Wabarakatuh.